Dear students, now we are going to see the course signals and system. Under that, the topic is classifications of signals. On classification of signals, on completion of this topic, the students can able to classify the continuous time signal based on properties and discrete time signals based on its properties. Continuous time and discrete time signal. A continuous time signal is defined for every instant of time is known as a continuous time signal, and the continuous time signals are continuous in amplitude and time. It is denoted by x of t. Example is sine wave. Discrete time signal is defined for a discrete instant of time, and it is also continuous in amplitude and discrete in time. It is obtained by sampling a continuous time signal, and it is denoted by x of n. The discrete time signal graphical representation is shown in figure. Here the signal x of n is defined only at discrete instant of time. Classification of continuous time and discrete time signal. Both are further classified into 5 types: deterministic and random signal, periodic and aperiodic signal, even and odd signal, energy and power signal, causal and non-causal signal. Deterministic and random signal. A signal is said to be deterministic if there is no uncertainty over the signal at any instant of time. That is, its instantaneous values can be predicted. It can be represented by a mathematical equation. Example, sinusoidal signal. Random signal. It is also called as a non-deterministic signal. It is said to be random if there is an uncertainty over the signal at any instant of time. Its instantaneous value cannot be predicted. It can be represented by mathematical equation. Example is a noise signal. Periodic and aperiodic signal. Periodic signal. A signal is said to be periodic if it repeats again and again over a certain period of time. Aperiodic signal. A signal is a signal that does not repeat at a definite interval of time is called aperiodic signal. Continuous domain. A continuous time signal is said to be periodic if it satisfies the condition x of t equal to x of t plus capital T, where t is the fundamental time period. If the above condition is not satisfied, then the signal is said to be aperiodic or non-periodic. The fundamental time period capital T is equal to 2 pi by omega. Here omega is the fundamental angular frequency in radian per second. Discrete domain. A discrete time signal is said to be periodic if it satisfies the condition x of n equal to x of n plus capital N. Here the capital N is the fundamental time period. If the above condition is not satisfied, then the signal is said to be aperiodic. The fundamental time period n is equal to 2 pi m by omega. Here omega is the fundamental angular frequency in radian per second. M is the smallest positive integer that makes n as a positive integer. Even, that is symmetric, and odd means antisymmetric signal. A continuous time domain. Even signal. A signal that exhibits a symmetry with respect to t is equal to 0 is called even signal. The even signal satisfies the condition x of t equal to x of minus t, and example is x of t equal to a cos t. Odd signal. A signal that exhibits antisymmetry with respect to t is equal to 0 is called odd signal. Even part xe of t and odd part xo of t of continuous time signal is x of t. The odd signal satisfies the condition x of t equal to minus x of minus t, and its example is a sin t. Even component of x of t is given as 1 by 2 x of t plus x of minus t, and odd component is given as 1 by 2 x of t minus x of minus t. Discrete time domain. Even signal exhibits asymmetry with respect to n equal to 0 is called even signal. Even signal satisfies the condition x of n equal to x of minus n. Odd signal. Odd signal exhibits the antisymmetry with respect to n equal to 0 is called odd signal. Odd signal satisfies the condition x of n equal to minus x of minus n. Even part xe of n and odd part xo of n of a discrete time signal x of n is xe of n, that is the even component is 1 by 2 x of n plus x of minus n, and the odd component of x of n is x suffix o of n equal to 1 by 2 x of n minus x of minus n. Energy and power signal. Energy signal. A signal which has a finite energy and zero average power is called energy signal. The non-periodic signals like exponential signal will have a constant energy, and also non-periodic signals are energy signal. For energy signal, the energy value is greater than 0 but less than infinity, and power is equal to 0. For a continuous time signal, the energy value is determined by energy is equal to limit t to infinity integral minus t2 plus t modulus of x of t the whole square into dt. And for discrete time signal, energy is equal to limit n to infinity summation small n equal to minus n to plus n modulus of x of n the whole square. Power signal. The signal which has a finite average power and infinite energy is called power signal. The periodic signals like sinusoidal complex exponential signal will have constant power, and so periodic signals are power signal. For power signal, power value is greater than 0 but less than infinity, and energy value is equal to infinity. For continuous time signal, the average power P is equal to limit t to infinity 1 by 2t integral minus t2 plus t modulus of x of t the whole square into dt. And for discrete time signal, average power P is equal to limit n to infinity 1 by 2n plus 1 summation n equal to minus n to plus n modulus of x of n the whole square. Causal and non-causal signal. A causal signal. A signal is said to be causal if it is defined for t greater than or equal to 0, that is x of t is 0 for t less than 0. And for non-causal signal is defined for t less than 0 and 0 for t greater than 0, that is x of t is not equal to 0 for t less than 0. When the non-causal signal is defined only for t is less than 0, it is called anti-causal signal. Discrete domain. A causal signal is said to be causal if it is defined for n greater than or equal to 0, that is x of n is 0 for n less than 0. Non-causal signal is defined for n less than 0 and or for both n less than 0 and n greater than or equal to 0, that is x of n is not equal to 0 for n less than 0. When a non-causal signal is defined only for n less than 0, it is called anti-causal signal. Quiz question. A signal is a physical phenomena. Thank you.